Hi students, welcome to Inside Physics. I am Srinivas. Today we are going to discuss about simple microscope, which is an optical instrument. This is a topic in ray optics and optical instruments from class 12. Okay. See, what is a simple microscope? It is an optical instrument. See, why we need optical instruments? Optical instruments are an aid of vision. So here the objective of simple microscope is to view the magnified objects. So objects should be magnified to view it sometimes more than the image object size. Okay. So that is the purpose of simple microscope. Why it is called a simple? That means, see, the object here, the lens is used as a convex lens which is of small focal length. Okay, a single convex lens is used, that is why it is called a simple microscope. Here our objective is, our aim is to magnify the object and view as per the magnification. It may be sometimes 5 times, 6 times, maybe 7 times, and the more magnification you can produce by a simple microscope is less than 9 times, less than or equal to 9 times. The maximum magnification produced by the simple microscope is maximum 9 times. So here we see how it works. Okay, first of all, if you put an object at focus of a convex lens, the image is formed at infinity. We all know the image formation rules. According to the rule, if an object is put at focus, the image is formed at infinity. Infinity means it is an undefined distance. We cannot see an object or image formed at infinity, so that we have to take the image just less than infinity so that we can view the image comfortably. Okay, the most comfortable distance for the eye as per the biological system is when the eye is focused at infinite distance. Okay, when there is also one distance called least distance of distinct vision. So this is 25 centimeters or more from the eye lens. This is called least distance of distinct vision, where our eye is comfortable viewing the objects, and this is greater than or equal to 25 centimeters. Even though the eye is comfortable viewing the objects at least distant of distinct vision, it will undergo some stress while viewing the objects at 25 centimeters. So the relaxed eye will be viewing the objects where they are at infinity. Okay, it will be more comfortable and relaxing for the eye if the eye is focused at the images at far away, that means at infinity. So in this case, for simple microscope, if we consider the image is formed at least distance of distinct vision, that means image is formed at 25 centimeters. Okay, we consider the linear magnification, how it is formed. Suppose if there is no lens and the object is having an inclination of theta naught at the eye, this is object height. Okay, so this is least distant of distinct vision, 25 centimeters. So the object is having a angle theta naught at the eye. This is called object angle. Okay, now for the image forming at least distance of distinct vision d, we will consider the magnification m. We know that m is equal to h dash by h is equal to v by u for a lens, right? So this means V by U we can write from lens formula. We know that 1 by V minus 1 by U is equal to 1 by F. So with this 1 into 1 by U, with this we can write V into what is U here? U 1 by U is 1 by V minus 1 by F, right? So this becomes 1 plus 1 minus V by F. Okay. We are having the linear magnification when the image is formed at a least distance of distant vision, that is D. So here we can say that V is equal to minus D. That means with sign convention we can say that the distance is minus D. So this becomes 1 plus D by F. So this is the magnification of simple microscope when the image is formed at D. Okay. Now if we have to have an image, we already told you that the image formed at D will be that much, not that much comfortable to the eye. So we want an image to view relaxably and comfortably for the eye. An image should be formed just before the infinity, that means closer to infinity. For that, the object is taken not at F but just nearer to the F and nearer to the optical center, closer to the optical center but just nearer to the focal length, focus here. Okay, then the image is formed closer to infinity. If you take at F, it will be at infinity. This diagram depicts that the image is formed at infinity and the eye is focused at infinity. Here the object is put at just below focus and nearer to optic center. This distance is very small, so the image is formed closer to infinity. Okay, then the eye will be viewing this image very comfortably and the image viewing is very relaxing for the eye. So here if the image is formed at infinity, that means closer to infinity, we have to consider the angular magnification for the simple microscope. This is linear magnification when the image is formed at D. When the image is forming at closer to infinity, we have to consider the angular magnification. Angular magnification is theta naught by, just a moment, theta I by theta naught. Theta I is angle subtended by the image at the eye and theta naught is the angle subtended by the object at the eye. We consider theta naught. Theta naught is equal to, see, if you consider this as theta naught here, this one, so it is the object size h by this distance u, but the without lens the object is, we can consider as, if you put the object as at D only without lens, we can view the object very clearly, so that the angle subtended by the object we can consider as h by D. So instead of u we are writing h by D, because in the previous diagram I have seen given you when the object is at D, least distance of distant vision, so the angle subtended by the object at I is theta naught. So we will consider theta naught is h by D. So actually this is tan of theta naught, this is h, this is D. And now if you consider this one, when the image is at formed at the closer to infinity. Okay. Now the actually this is not the angle subtended by the object. The actual angle subtended is tan theta naught is equal to h by minus u. This is the actual angle subtended. We can ignore minus h by u. Okay. See, but we consider the object angle as h by d. Okay. Now, if we consider the image angle subtended by the image, that means tan theta I. Okay. So tan theta I is h dash by minus v. See, v is the image distance here. E is the image distance. Okay. So where is the image formed in this case? Suppose this is in this case, if it is the closer than infinity, we can say the image is minus v, and this sign is according to the sign convention. We know for angular magnifications h dash by h is equal to m is equal to v by u. Okay, for lens. So from this we can consider h dash is equal to h v by u. So this h dash is equal to h v by u. In place of h dash I will put h v by u. So here h v by u into minus v, that is that it becomes h v gets cancelled, h by minus u. Okay, tan theta I h by minus u. Okay, so here minus u is nothing but focal length f. Okay, h by this becomes h by f. Okay, so here for small angles, very small angles, we can write this one as theta naught is equal to h by d, and for very small angles again theta I is equal to h by f. Okay, so we need the angular magnification theta I by theta naught. So angular magnification m is equal to theta I by theta naught. Okay, so what is theta I here? H by f by this is h by d. Okay, so this becomes d by f. So angular magnification has become d by f. This is equal to d by f. Okay, so if we see the linear magnification, what we have got, linear magnification 1 plus d by f. Okay, we have got the linear magnification ml. So and angular magnification, what we have derived, that is m is equal to d by f. Okay, if you observe both these relations, see the angular magnification when the image is formed at infinity is 1 less than the linear magnification. So even though we have one magnification less when the image is formed at infinity, so the object is placed just before the focus and nearer to the optic center, so the viewing is very relaxing and comfortable to the eye, even though the magnification is 1 less than the linear magnification. Here the angular magnification is 1 less than the linear magnification. Okay, this is about the magnifications of the simple microscope, how we will form an image while putting the object nearer to the convex lens. And here the eye is placed, our eye with which we want to view the image is placed very nearer to the lens, other side of the lens. Okay, and the object is placed always, generally it is placed one focal length or less than one focal length. The object for a simple microscope is always placed one less focal length or less than one focal length. This is the basic principles of simple microscope. Okay, so I already told you that the maximum magnification generally produced by the simple microscope is less than or equal to 9. That means it can produce the image maximum 9 times the object size. Okay, magnification means number of times the object is multiplied by the image to the image. Okay, so this is the construction and theory of simple microscope. So in the next class we will see what is a compound microscope. Okay, thank you.